Large language models. So basically, a large language model is a deep learning algorithm that can perform the variety of NLP tasks. They uses transformer models and are trained using massive data sets. So that is why it's called large, because they are trained on this large amount of data set acquired from GitHub, Wikipedia and other sources, which enables them to recognize, predict or generate text and other content, say generating codes or retrieving the information, etc. Next, now what is transformer model? So the transformer model is the most common architecture of this large language model. So you must have used different large language models like Zephyr, Llama and other things, and you will find that they all are based on transformers. So in this transformer model, it first processes the data by tokenizing this input and then conducting some mathematical equations to discover that relations between the tokens, which enables the computer to serve the patterns and human will understand if it is given a query. Suppose a person is told who is the PM of India. So you will just think about the information that you have got through news or other things and will give the answer. So similarly, it uses the same. So transformers, they work with self-attention mechanism, which enables the models to learn more quickly than traditional methods like long short-term models. Self-attention means which allows the transformers to consider different parts of the sequences. So if we understand this transformer, it has an encoder-decoder architecture and it processes the data by tokenizing this and discovering the things. So this is in short the transformer architecture. So basically we understand the transformer has an attention and the position wise feed forward neural network. So suppose we are given an attention matrix and we are given an input matrix. So we will have a product matrix multiplication, like we'll multiply this 5 with 1, 6 with 1 and all will be 0, so it shall be 11 here. So it's just a matrix multiplication. Now we have got this attention weighted matrix features here. Now we will multiply this with the position wise feed forward neural networks. If we consider here the number of columns are 4 and here number of rows are 3. So we can just multiply this 3 columns with this 3 rows and can consider the last one as the bias. That is, we will use the formula y is equals to wx plus b, right? So we will have this one. So 11 minus 2, that is 9, plus b plus 1, that is 10 here. So similarly we'll do this for other things, and also consider in the ReLU we consider the negative values as 0. So that is why where there is a -1, -4, we have considered them as a 0 here. Now we have a second layer of this feed forward neural network. So here also we observe that number of columns are 5 and here number of rows are 4. So just multiply this 4 columns with the 4 rows here. Considering the last one as a bias, we will use the formula y is equals to wx plus b. W is the weight, x is the input layer, b is the bias here. So multiply 10, then here 0, 0 and also 0 here, right? So 10, answer should be 10 because we are adding just 0 here. So this way we can calculate the transformer model. Now what are the components of this LLM? So first component is the embedding layer. Embedding means which creates this embeddings from the input text. That is, it is capturing the semantic and the synthetic meaning of this input so that model can understand context. What are you talking about? What is the context of the things? So for this it uses embedding layer. Embedding means understanding the context. Second is feed forward layer. Means it is enabling the model to glean higher level abstractions. That is, it is trying to understand the intent of the user with a text input, what it wants to understand. Suppose if it wants it to generate a code or want to just write a cover letter or something like that, what's the intent, what it wants to do with this data set. So for this we use feed forward layer. Embedding means understanding context. Feed forward layer means understanding user's intent. Then we have recurrent layer, means we are capturing the relations between the words in the sentences. Suppose he went to the temple. Now he and temple. So how they are related? He went there, right? So we are understanding the relations between the words. Then attention mechanism, which is trying it to focus on that single part that is relevant to the task at hand, so that the model can generate the most accurate output. So these are the components. So by now we have understood embedding means understanding context, feed forward layers means understanding users intent, recurrent layer means understanding the relations between the words, and the attention focus on the relevant task only, right? Now what are the kinds of this large language models? So it can be generic, instruction tuned, or dialogue tuned. Now the generic or the raw LLM means which will predict the next word. So it can be used for the information retrieval task. Then an instruction tuned, which allows it to perform the sentiment analysis or to generate text and codes, because they are trained to predict the responses based on the instructions. Then we have a dialogue tuned LLM like the chatbots, so which are trained to have a dialogue by predicting the next response. Hi, how are you? I'm fine. What about you? So these are the dialogue tuned LLMs. Next, how do large language models work? So basically, this large language models, they work by receiving the input and then encoding it and then decoding it to produce the output predictions. Like as we have shared, it has encoding decoding part there. But before LLM can receive this text and generate this output, it requires some training. So there's a training part. So basically large language models, they are pre-trained using large text data from the sites like Wikipedia, GitHub and other sources. So it has the trillions of the words and their quality will affect the large language model performance. The more the data, the more accurate it is. So next is the fine tuning. Fine tuning means in order for the large language model to perform the specific tasks, it must be fine tuned to that particular activity. So fine tuning basically optimizes the performance of specific task. Then we have a prompt tuning, which will fulfill the similar function to fine tuning, but here it trains a model to perform that specific task through few shot or zero shot prompting. Now you must have read the term about the generative AI. So what's the difference between the LLM and the Gen AI? So we must know that Gen AI is just an umbrella term that refers to these AI models that have the capability to generate something like ChatGPT. And this large language models, they are a type of this Gen AI which are trained on text only. So large language models type of Gen AI working on text only, like ChatGPTs are there. So you must have understood that this more the data, more accurate the large language model. It has training, fine tuning and the prompt tuning. Next, its used cases. So first use case is the information retrieval, like we use Google. So whenever we use their search parameters, you are relying on this large language model to generate that information in response to your query. Like suppose I say write a Python code to add two numbers. So based on its learned information, it shall give you that Python code. Next is a sentiment analysis, that is to analyze the sentiments. The person is finding the shopping app. So in the shopping, whenever there is a sale, it has a positive feedback, and when the prices got double, it has negative feedback. So we are understanding the sentiments when people are positive or negative. Then text generation, like they can produce an example of the text when prompted. Write me a poem about this palm or write something. So it can generate the text, then it can generate the codes also. And next, the technologies where it is used. So first thing is the tech space, that is we can write any code. Then in the healthcare and the sciences, that is it allows LLMs to assist in the development of vaccines for the illness. like we must have read about the coronavirus vaccine, right? It's we had just checked its symptoms, like it has cough and other things. So based on the chemicals that were used to cure this cough, that were used to cure the fevers, finally a chemical was made which is an amalgamation of all these chemicals used to cure the previous disease, and then corona vaccine was made. So this way we can use this large language models. Then in the customer service, like chatbots, conversational AI, my phone is not working, I want a customer representative number. Sure, as per your query, you must try this, that, like this. So it's a customer service type of apps. Then in the marketing, suppose we can generate the campaign ideas, or we can provide the pitch examples, or can do the sentiment analysis. Then in the legal part, it can assist lawyers, paralegals and legal staff. Then in the banking, it can help in detecting fraud and can support this credit card companies. Or finally, it's the chatbots and the conversational AIs. Then what are the benefits of this large language models? They're always improving, because day to day the new data will be added, and the more it shall learn, the better it shall get. So this large language models, their accuracy will keep on improving, for it's continuously learning, and they learn very fast, in the sense it does not require too many examples, and they're trained on the large set of applications, so they also give very high accuracies. But there are certain limitations of this large language model. The first limitation is hallucination. Hallucination means it is producing an output that is false, or it does not match with the user's intent. For example, claiming that it is human, it has emotions, and it is in the love with the user. Because large language models, they predict the next synthetically correct word or phrases, they cannot wholly interpret that human meaning. So sometimes it can result a hallucination, because we know we humans have emotions. Sometimes if the judge just don't use the emotions, under what circumstances that person did a murder or something like this, was it a self-defense or something like this, or what were the circumstances, if it won't you understand everything, it may take the wrong decision. So that is why here also, if it's a we are trying the LLM, they should have used this human reasoning, but still they are not able to do so. They sometimes gives the wrong output. Then security, because they can leak the people's private information, so they can participate in the phishing scams and produce the spams here. And the users with this malicious intention, they can reprogram AI to their biases and can contribute to the spread of misinformation, so which can be very devastating on that global scale. Then bias, of course, if the data will represent a single demography, or it will not have a diversity, so it may lack the diversity and can be biased. Then can consent. So sometimes when scraping this data from this internet, so they are betterly known to ignore this copyright licenses, plagiarizing this written content and other things. So it may produce the output, and but there is no way to track the data lineage, and often no credit is given to the creators, so which can expose the users to copyright and infringement issues. And also it has been seen that LLM has already run into the lawsuit, including a prominent one by the Getty Images for violating this intellectual property. Then is the scaling. It is like it can be very difficult and time consuming and the resource consuming to scale and maintain such large language models. And finally, it's in the deployment. Like deploying these large language models, they require deep training and deep learning, transformer models, distributed softwares and hardwares, and overall technological expertise. Now, examples of this popular LLM. First is the Google Palm, that is a transformer language model which is capable of common sense and arithmetic reasoning, joke explanation, code generation, and translation type of things, performs very well. Then a BERT GPT, that is a bidirectional encoder representation from transformer models generated or developed by Google, so that can understand languages and can answer the questions. And then ExcelNet, which assesses the patterns of this token and then predict the token in a random order. and also the GPT, like GPT-3, GPT-4, we all know, which are fine-tuned to perform that specific task downstream. Like we can use this Bloomberg GPT for finance and other things. Now, what are the future advancements in this large language model? First is the increased capability, because as impressive as they are, the current level of technology is not perfect, so they will keep on learning, they will improve their performances, they will reduce the bias, eliminate this incorrect answers, so their capabilities will improve with the more training and other things. And then audio visual training, currently developers are training this LLMs using text only, but they have also started training models using video and audio inputs. So in the future we can see that LLMs are used for autonomous vehicles and other things. And then the conversational AI, definitely it will be better able to interpret this user intent and respond to sophisticated commands. And finally the workplace transformation. So LLMs will definitely reduce this repetitive task like clerical tasks, customer service chatbots, and simple automated copywriting based jobs. So definitely it has a future scope. So that's all for today. So thank you.